Hello, everyone, and welcome to an ASBOG Fundamentals of Geology review for Glacial Geomorphology. So what I've done is I've compiled about 40 questions from various sources, some of them uh, from exams from different universities that I found online, um, as well as some of my old test questions from when I took geomorphology as an undergraduate. Um, and I was going to use them from their original source, but not all the questions were really related um, to what the ASBOG is going to be asking you. So I kind of compiled them, changed up some things to make them my own, and I'm going to walk through kind of like what I did with the ASBOG practice exam, just kind of give my thoughts where I think it's necessary. But kind of the purpose of this video is to give people who either didn't have the opportunity to take geomorphology, or maybe they didn't cover glaciers in their geomorph class, or um, in any case, maybe even a review. But for people who are, I know some candidates who are going to take the FG exam here pretty soon who would like a review of glacial geomorphology. And so at first, I started constructing a lecture, and it was getting pretty lengthy. And then I decided to go this route, since people will be asked multiple choice questions on the ASBOG, maybe it's best that you learn the way that you're going to be tested. I know there are some studies that support that thinking. So I'm going to go ahead and try this out, see how this goes. Maybe it's a dud, maybe not. Who knows? But the purpose of, or at least what I'm wanting you to get out of this exercise is familiarity with erosional and depositional landforms that we see in alpine and continental glaciation. Um, the ASBOG exam only really focuses on on those two concepts. Um, I can't imagine there being too many questions about any internal mechanics, concerning glaciers, or glacial mass balance. But I've included some questions there just to maybe give you a little bit more of a comprehensive understanding of what's going on, but nothing too in depth. I think someone without a glacier background can take away a lot from this exercise. But enough of me rambling. Oh, excuse me. Enough of me rambling. Let's just go ahead and get on into the questions and see what we can do. All right. Which of the following depositional features would you look for to assess whether an area had undergone glaciation? So, well, my first instinct says all of these things are associated with glaciation, so I would choose D. But that would be wrong. And that would be wrong because it specifically asks for depositional features. So while all of these may be associated with glaciation, I have to be more careful. That's something I definitely would do, would just be like, oh, yes, all of these are glacial related. They're going to tell you, oh, yeah, there definitely was glaciation going on in the past. And while that may be true, we're looking at depositional features. Horns, arêtes, or coals, these are all erosional features. Whereas a terminal moraine, that is a depositional feature, and moraines are associated with glaciers, and so the correct answer is C. So I'm just going to highlight. All right, alpine glaciation, ... is found in mountainous regions, exists where a large part of a continent is covered by glacial ice, is a type of glacier, cannot be found on Earth today. Definitely can be found on Earth today, so D is incorrect. Alpine glaciation, if it said alpine glacier, sure. I mean, you do see alpine glaciers and alpine glaciation, but that's just getting kind of technical, so it's not C either. Exists where a large part of a continent is covered by glacial ice. So alpine glaciation is reserved, or well, maybe I shouldn't say reserved, is restricted by the subglacial land surface. In other words, it is constricted by valleys and mountains. And so we see that in mountainous regions. So alpine glaciers, you might also hear them referred to as mountain glaciers, valley glaciers. Those kind of terms are all interchangeable for the most part, and people use them interchangeably. So the correct answer for this, for number 2, is A. All right. Erratics are blank. Crossbeds which do not match. Large boulders just posited randomly. Valleys with glacial striations that oppose conflicting dates. So all of these responses were really over the place, and that kind of, that's ironic considering what we're being asked. But erratics, how I think of erratics is just like if I would use the word, in everyday language, if I said something was erratic, it's, it doesn't really have an order to it. And so even if I didn't know what any of these things were, I could probably be pretty confident that it's going to be B, just because we have that word randomly in there. And I would be correct. The correct answer is B. All right. A line marking the highest point at which a glacier's winter snow cover is lost during a given season is called the what? Ablation line, line of retreat, snow line, end of forest line. All right, so I'm going to say it's not D. I don't know. Yeah, no. Immediately, when it starts talking about snow cover being lost, I start thinking of ablation, because that's what's happening with ablation. But really, what this is trying to say, I think ablation is the trick answer here. Because the snow line, that's going to be the farthest advance of snow cover that we're going to be that's visible. So C. I feel pretty confident. There we go. All right, we'll move it up a little bit. If the amount of water and ice a glacier loses is greater than the amount of snow it gains, the glacier will do what? Okay, it'll either advance or retreat, remain unchanged, or retreat and then advance. Okay, so it's not gonna, so let's see. If it loses more than it gains, it's going to decrease. And you can think, so this is kind of like a glacial budget question. This is glacial budget is also referred to as mass balance. And you can think of it like budgeting your bank account. If you are losing more money than you are making, your bank account amount is going to decrease, unfortunately. And the same is true with a glacier. If you're not continually feeding and nourishing that glacier with fresh snow, it will retreat. So the correct answer is B. There we go. Highlight. Thank you. Plastic flow occurs in the upper part of the glacier, where crevasses are common, at the interface between the underlying bedrock and the glacier, in the lower part of the glacier between the interface with the bedrock and the overlying zone of rigidity, at the bottom of the glacier when basal sliding is present. Okay. So what is this question really asking? This question is asking specifically what part of the glacier do we see plastic flow? And maybe right away we don't we don't remember exactly where that occurs. We can think about a glacier that's flowing. So maybe a valley glacier or an alpine glacier that's flowing down mountain. So the bottom of a glacier is going to have some meltwater um, generally, because as you have you're building up pressure, you're going to see some melting at the bottom, and that's going to help things kind of slide along. Um, but also we have to take into consideration, by definition, what is a glacier? And I know that seems kind of tangential to what this question is asking, but let's pause kind of, because this is review, and think about what is a glacier. So a glacier is a large land mass, has to be on land, of accumulation of ice that accumulates year by year. It's there perennially, and it moves, whether internally or on the land surface. And not all parts of the glacier are going to be moving. And so the very top of the glacier is going to be really brittle. I'm afraid I'm getting ahead of myself here, and because I think there's some other questions that'll help demonstrate this better. Um, so let's just go ahead and tackle this one, and we'll use that knowledge for some of the later questions. So plastic flow occurs in the lower part of the glacier. And this is in part because of where we see some melting and due to all that pressure on that continually layered snow that builds up. So number 6, C, is the correct answer. Glaciers that are confined to valleys are called alpine glaciers, ice sheets, ice caps, or continental glaciers. So ice sheets, ice caps, and continental glaciers all go together. So ice sheets and ice caps are continental glaciers. The difference between these two, between B and C, is their size. So ice sheets are very massive. They are greater than 50,000 square kilometers. So think like the Antarctic ice sheet or Greenland ice sheet, where ice caps, they're very similar, but they are differentiated based on their size. So ice sheets are greater than 50,000 square kilometers, where ice caps are smaller than 50,000 square kilometers. But in any case, the question here is asking you to know that valley glaciers are also called alpine glaciers, which I think I've already said a couple times, but at least you'll have that memorized. So A is the correct answer. All right. And it looks like that's important for this next question. So glaciers that are not confined to valleys and cover less than 50,000 square kilometers are called what? So I guess pause. Do you remember what I just said about which is smaller than 50,000? Well, non-valley, that's a trap answer. Valley, no, because it's not confined to the valley. And we're looking at the one that's smaller. So we're looking at ice caps. Okay. A continental glacier is distinguished from an alpine or valley glacier by choose all at the. So I guess if you didn't know, the answers to the other ones, you'd be able to get that information down here. So, and so I guess I will pause and say that these questions, not all of these are maybe the same quality of question that you would be seeing on the ASBOG, but I think these types of questions do give you sufficient background that you could answer an ASBOG quality question. But anyway, I digress. So what makes a continental glacier different from a valley or alpine glacier? Definitely size. So continental glaciers, as the name implies, they generally cover continents, and they exceed 50,000 square kilometers. but they are not confined by the subglacial land surface. So they're not confined to valleys. Um, and they are long lasting. So A, B, and C. Or wait, sorry, A, C, and D. All right. Um, which of the following list is written in the order of increasing metamorphism? And obviously, we're not talking about metamorphism in like contact metamorphism sense, but rather in more of a changing of shape and composition. Not well, changing of shape. Um, so we have snow begins the list for every single one of these. Let me see, granular ice, firn, or glacial ice. Um, so not everyone would use granular ice in their list. Some people would only include snow, firn, and glacial ice as the increasing transition, and this refers to increasing density of snow. And so what's happening here is that snow that survives the year is going to undergo recrystallization, and it's going to become more rounded. It's going to settle more, and it's going to first it'll be fresh snow, and then it'll turn into fern, and so yeah, granular ice is the one that's odd. So granular ice, what it's referring to there is that it's starting to lose its particular snow flaky appearance. It's starting to round off a little bit, but would still be recognizable as snow. Um, and so, for those of you who maybe think maybe more quantitatively, new snow is going to have a pretty low density. We're talking 0.05 grams per cubic centimeter to 0.07, where fern is about 0.4 to about 0.8 grams per cubic centimeter, with glacial ice being around 0.9 grams per cubic centimeter. Um, so maybe that's more helpful to some people than just memorizing the order, but generally, I would say personally, snow, fern, and then glacial ice. But for this particular question, we'll have to consider granular ice, which is kind of an intermediate between snow and fern, as the correct answer is A. All right, the transformation from ice to a gaseous water vapor is called, so it's not melting, that's ice to water. Boiling, that's water to gas. Sublimation is what we're looking for here. So this is, if you've ever lived in like maybe in the the northern United States where it snows frequently, um, snow, maybe some of it will melt, but then also some of it just seems to disappear, and that's just where snow is just undergoing sublimation. It's just going straight into a gaseous state. So B is our correct answer. Which of the following is not a form of ablation? So ablation is referring to the removal of snow. So melting, that removes snow. Sublimation removes snow. We just talked about that. And then calving, I don't think we talked about that yet. So calving, that's essentially where a big chunk of ice will break off of a coastally terminal glacier. So if there's a glacier that's ending in a body of water, and some of the ice breaks off and turns into an iceberg, that process of it becoming an iceberg is calving. So it kind of breaks off. So again, that's also considered a form of ablation. And so when I'm talking about like the removal of ice or snow, I'm referring to like a quantitative amount that's being taken away. So in this case, calving is a form of ablation. So it looks like D is the correct answer. Oops. All right. What is the name for the amphitheater-like hollow that forms at the head of a glacier? So an amphitheater is kind of like a low-lying, based on like type arena. So I don't know if I would use this kind of language for this, but that's just the question that was on the exam. But and the head of the glacier is more like the head wall. So you have like a wall coming down, and then there's some type of depression. So if we look, we have kettle, moraine, cirque, or horn. So horn, as it seems to imply, is something that's going to be spiky. It's going to have a point to it. It's not going to be some type of depression. A moraine is a depositional feature. And then a kettle we see from the while a kettle is a depression, it forms because of the retreat of a glacier in like an outwash plain. So not at the head of a glacier. A cirque is what we're looking for. All right, which of the following can be used to determine the direction a continental glacier has moved? Striations, that seems, I feel very confident at least A. Since Z is all of these, let's consider what these two are. So roche moutonnées, they are the result of abrasion on the Stoss side, an intense quarrying and plucking of a steep lee side. And those are erosional features. And so they do occur in continental settings, as well as drumlins. So where drumlins are a depositional feature, they're kind of elongate features that you'd be able to tell the direction of glacial flow. So yes, you could use all of these. All right. In a continental glacier, ice flows from the edges to the center, from the center to the edges, north to south, south to north. So in a continental glacier, in the center, if you look at my cursor, ice essentially in the very center kind of moves vertically downward and then moves outward towards the center. And that's just due to gravity. And because they're so massive and there's so much snow and ice accumulation, so they flow from to the edge, or to the center to the edges. So 15 is B. Okay. 16. When two cirques at the head of an adjacent valleys meet at the mountaintop, they produce a sharp, jagged crest called a what? Um, so let's see. Let's look at the ones that we've already covered before. So we've talked about moraines, and that those are kind of lobate, elongated depositional features. Sorry, no, let's back up. Those are drumlins. Where moraines are depositional features as well. A fjord, which is a fun word. There's a couple different ways to spell that too, but that's just one of them. A fjord is a glacial valley or glacial trough that has been filled by ocean water. So of the three that we've talked about, leaves an arete, which is true. And there should be an accent on the middle E, but oh well. All right. Kettles are formed by what? So we talked about kettles earlier, so that's helpful. Meltwater streams, large blocks of ice in an outwash plain, seasonal deposition, melting permafrost. So we know that kettles are formed by the retreat of glaciers in an outwash plain. So B is our correct answer. Large masses of ice on land that show evidence of movement are called what? Ice packs, glaciers, icebergs, or all of these things. So it can't be an iceberg because we are specifically on land and we're showing movement. So it is a glacier. If you can hear the sirens in the background, I apologize. There we go. A deposit of snow contains approximately 90% air. Knowing that, glacial ice, which forms from snow, technically forms from fern, but we'll ignore that, contains approximately how much air? So you have to think about what's happening here. So, you are becoming more and more dense. You're leaving less and less room for air. And essentially, once you have glacial ice, you're essentially going to have minuscule air bubbles that are going to be remaining. So not a significant fraction of the whole. So definitely, probably, I think it's pretty safe to say that it's going to be less than 20%. The cross-sectional diagram to the right depicts what glacial feature? So looks like, so we have some abrasion over here. That's what that helps give us this smooth, polished surface. And we have ice that's going this direction. So we have abrasion over here, and we see some plucking and quarrying over here. That sounds like a roche moutonné that we talked about earlier. And but let's just make sure. Let's see what we're talking about, or that at least we know what we're talking about. So an esker, that is a sinuous ridge. And then a came is a irregularly shaped hill that forms as the result of a retreating glacier. Yeah, so no, this diagram is showing, oops, I don't want to do that, whatever, I just, there we go. So roche moutonné is the correct option. And then I don't know if we've discussed drumlins yet, but drumlins, those are elongated hills. Some people say they look like an inverted spoon, but I guess I see it. But I see more of a teardrop shape. They're composed of sand and gravel. primarily just composed of glacial till. But in any case, moving on. So which feature forms where two lateral moraines merge? End moraine, medial moraine, ground interlobate. So all of these are different types of moraines, and I think if we don't know anything, let's say we don't know anything about moraines, and we just know what we're being asked where two of these moraines merge. To me, the first one that pops out is a medial moraine, and I know that medial moraines are where is the ridge of a moraine that kind of cuts down where two glaciers meet, and kind of their debris it makes that ridge. And that's what a moraine is it's this narrow zone of debris. And so what we're seeing for the medial moraines is when we have two lateral moraines that join at some intersection of the ice streams, we're gonna see that medial moraine. Interlobate moraine, that's where we have two or more ice sheets that make contact with each other, but that's not a medial moraine. So that's a good option, but medial moraine is where they merge. So B is the correct answer. Which of the following is a glacial deposit and not a glacial erosional feature? A cirque, moraine, arête, or horn. All right, so these are all terms that we've talked about briefly before. So we're looking for a glacial deposit. So a cirque, that is an erosional feature that we talked about where we have a glacier head and then we have some kind of depression. It's what they called an amphitheater-like depression. A horn, that's a peak. So that's going to be the result of erosion. And then arête, I think we talked about an arête up here as well. Let's see. Maybe I'm making that up. Nope. So it's where they, adjacent valleys meet at a mountaintop producing an arête. So yeah, we talked about arêtes before. And then a moraine. So we talked about moraines too, and that is a depositional feature of till. So B is our correct answer. Large streamlined hills of till and bedrock that form in areas subjected to continental glaciation are called what? So streamlined always refers to continental glaciation features. So you may be asked about streamlined features. I know that's I think that was a question on a practice exam. So that's a good key word to take note of. But in this case, they already went ahead and told you that it was a continental glaciation. So arêtes, cames, and eskers, all of these form an alpine glaciation. And if I didn't know what a drumlin was, I just knew which type of glaciation all of these went with, I'd be able to correctly answer this one as D, drumlins. All right, let's move on. Glacial erosion creates what type of valley and cross section? W, U, V, or S. So it's not going to be W. It's not going to be S-shaped. It's either going to be U or V. And V-shaped we generally associate with fluvial environments because of downcutting and erosion. Glaciers tend to erode more on the bottom than they do the sides. And that's just kind of in part, ice by itself is not very hard. It's like 1.5 on Mohs hardness scale at freezing temperatures. Um, so not exactly the best erosion or abrasive feature. What really starts to be impactful is depending on what types of material is being dragged along at the bottom of a glacier. And that depends on what it plucks or quarries out, and kind of just drags along. And also depends on what the bedrock surface that it's being eroded. If it's very uniform, or if it has a lot of different compositions throughout, you'll see some variation in erosional features. But it forms U-shaped valleys, or things like fjords, or glacial valleys. Those are, let's say, glacial troughs. All of those terms are synonymous. So U-shaped valleys. At present, what percentage of Earth's land surface is covered by glaciers? 1055.1. Well, Antarctica is essentially mostly covered by a continental glacier. So I definitely don't think it's very small, but I also don't think it's very large. So I think, this really is just a recall question, but you can kind of reason through it. It's not going to be very significant, at least significantly large in terms of like 50%. It's also not going to be extremely small, like 0.1, but the answer is 10%. The boundary between the zone of ablation and the zone of accumulation is called what? So the zone of ablation, even if we haven't heard ablation in this sense, we've talked about it before, where ablation is the removal of ice, and accumulation, we probably already know what that means. So in the zone of ablation, that's the area where ice is being removed or melting, and the zone of accumulation is where snowfall is actively being layered and actively falling and contributing to that glacier. Then it's asking for the line that demarcates the two. Fall line, no. Tree line, we're not talking about trees. Glacial compensation point, that sounds really fancy. And maybe that's what it should have been called, but it was called the equilibrium line. And that's where both of the zone of ablation and zone of accumulation are equal. And that makes sense because when we're considering whether a glacier is retreating or advancing, we're comparing those two zones. And if one is greater than the other or less than the other, that's how we determine glacial advance or glacial retreat. So that makes sense. Crevasses form in the surface of glaciers because near surface ice is easily melted, very cold, behaves as a plastic solid or as a brittle solid. So A and B, whatever. Yes, it maybe it is very cold, and maybe it does easily melt. Who knows? But really, what we should be considering here is, why are these crevasses forming? And so what's happening is, as glaciers move along, or maybe they're coming down a mountain slope, maybe they have to turn around a corner, maybe. Well, what's going to happen? That plastically flowing bottom is going to be able to make that turn relatively easily. But what's happening is that glacier, the uppermost part of that glacier, is essentially taking a ride on this conveyor belt of ice as it moves down slope, as a result of its own weight and gravity. And so what happens to form crevasses is when glaciers they move around a corner, the near surface ice is going to start to break because of tension and shearing that's occurring, because it's not moving. It's not as easily flowing, is relatively speaking, as the most bottom part. And so it's behaving very brittly and not plastically. So hopefully that clears up what I was trying to talk about earlier. Um, so the near surface ice behaves as a brittle solid. All right. The grooves in the bedrock illustrated in this figure are produced by the grinding of rocks caught up in the flowing glacier against the solid bedrock below. What are these grooves in the polished glacial surface called? Moraines, till, satellites, or striations? So we talked about moraines. Okay, so that's depositional till. And then what's till? That's just an unsorted, unstratified deposition of, clay and sand and gravel. Stylolites, that's a nice word. Maybe I don't know what it means. So maybe I would choose that one. But in this case, I do remember that satellites are a pressure dissolution feature that kind of forms this sawtooth looking line feature in rocks. And here we have very straight kind of ridges almost that are formed, they're polishing this rock. And those are called striations. Ooh, did it again. Dang it. Okay. What USCS classification would best represent till? So United States, United Soil Classification System, something like that. So this question is asking you, what type of symbol would best represent a till? So SC. So SM is a silty sand. SC is a clayey sand. CL, that's a clay. GC, so that's a silty gravel and a clayey gravel. And then an SP is a poorly graded sand. So till is not poorly sorted, it is unsorted. It has literally no classification of sorting. It's just unsorted. If you could think about the worst possible classification of sorting, that's till. But what is till made of? So till, you have to think about what types of things are going to be picked up and deposited by glaciers. So you will have some fine grains, but also, gravel sized, and in some cases even boulder sized. But till generally, for the choices we have here, it's not going to be a silty sand or a clayey sand. Definitely going to be looking at some gravel sized particles. So C is our best bet. All right. A glacier confined in a bowl-shaped recess is called what? All right, so we're seeing some overlap in some of the questions. So we talked earlier about an amphitheater hollow, and this question is talking about a bowl-shaped recess. All of these are really maybe not the best way to articulate. What we're talking about is a cirque. And that's just a depression that's near the head of a glacier. And so when we have a glacier that's in that cirque, in that depression, that's called a cirque glacier. All right, 10 more to go. A valley glacier that extends beyond the confines of its valley and coalesces with other valley glaciers along the base of a mountain range is termed what? So it's not going to be called a valley glacier. That's literally in the question. And it's a type of glacier, so it's not an ice field. And we talked about cirque glaciers and how those are glaciers that take up space in that depression. And so our only viable option here is a Piedmont Glacier, which is the correct answer. Which of the following is not correctly matched? An ice sheet, a significant isostatic depression of the crust. That makes sense. Ice sheets are very, very thick. We're talking kilometers thick. So they do have the ability to influence isostasy, so pressing down on the crust. We see, as glaciers melt, we do see isostatic rebound where the crust is starting to, is bouncing back upwards. So that's true. Ice cap completely buries the underlying landscape, but covers less than 50,000 square kilometers. That's true. We do know ice caps are smaller than 50,000 square kilometers. They're smaller than ice sheets. A came, a stratified serpentine-shaped deposit. That doesn't sound right. But let's consider D before we commit. A fjord says it's a submerged glacial trough or valley. That's absolutely true. So it looks like D is incorrect. So what is D really talking about? So D, a stratified serpentine-shaped deposit, that is talking about an esker. Whereas a came is that conical ice contact deposit of hill. So C is the incorrect answer in this case. Continuous ice sheets, ice caps, and ice fields are drained on their periphery by Piedmont glaciers, mountain glaciers, outlet, valley. So we know 3 out of the 4 we've talked about. We know Piedmont glaciers are ones that extend beyond the confine of a valley and coalesces with other valley glaciers. Mountain glaciers, those are continental glaciers. Those are alpine glaciers. Valley glaciers are also alpine glaciers. Outlet glaciers, if you just saw that on its own, you might think that's a trick question, but it is, in this case, the correct answer. They do drain ice fields and ice sheets. So outlet glaciers. Relative to glacial mass balance, which of the following is incorrect? A positive net balance occurs during a cold period and a negative net balance occurs during a warm period. Well, that makes sense. If, during cold period, snow is more likely to be deposited and stay frozen and maybe go under recrystallization and compaction. Where it's really warm, it's probably gonna have a lot more melting. So that makes sense. Glacial mass is reduced by evaporation, sublimation, and deflation. That's absolutely true. If you're taking away ice and snow, that's going to decrease the glacial mass. Glacial mass is reduced by a combination of processes called ablation. That's the same thing as B, that's just different wording. So ablation is referring to the removal of ice. So ablation is just kind of like an umbrella term for evaporation and sublimation and calving and deflation and such. So D better be the incorrect answer, or the correct answer. Well, in this case, incorrect. Worldwide, most glaciers are showing marked net increase in mass at present. They are absolutely not. Unfortunately, they're melting. Sorry, that's unfortunate. But it's the truth. A visible snow line across the surface of a glacier is called an equilibrium line, medial moraine, a firn line, or an ice line. Ice line, that's too easy. That's a trap answer. Equilibrium line, we already talked about that. That's where the zone of ablation and the zone of accumulation are equal. Medial moraine, that's the coalescing of or the ridge of 2 coalesced moraines. And a firn line, well, the visible snow line across a glacier. Which of the following are erosional landforms created only by alpine glaciation? This, I think, is a really good ASBOG question. It didn't come from an ASBOG exam, but it is certainly one that I could expect to see on one. So Let's see, erosional landforms. So let's see if any of these are not erosional. So ground moraine, so moraines are depositional. So till plain, those are the same thing as ground moraines. So definitely not C. Esker is that sinuous serpentine, type formation. And then drumlins, those are depositional. We're looking at coals and horns. Those are erosional. And you can think of if you didn't know what a coal was, actually, I don't think we've actually talked about coals and horns very much. So coals, those are narrow edged, like sharp edged depressions between the head of a cirque and an arête. And a horn is a sharp peak. It's the high point in an arête, which it's been sculpted by erosion of 3 or more cirques. It kind of has this like pyramidal shape, and so those are alpine glaciated erosional landforms, whereas drumlin and eskers and moraines, those are all depositional. So D is our correct answer. The material in a glacial moraine is what? Well, we know that moraines are made up of till, and we discussed in detail earlier what till is. So till is not subangular, angular, or well-rounded. It is unsorted. All right, unsorted and unstratified glacial deposits, not landforms, are called what? All right, okay, maybe whoever made this exam that I took this from, you were going easy on your students. It's till. I think we've covered that. All right, last two. Which of the following is not a depositional feature by or in association with a continental glacier? Unstratified till, outwash plain, lateral moraine, esker, or kame. So eskers, outwash plains, and kames are all depositional features in continental glaciation. So it's not B, D, or E. Or a lateral moraine that is not, so it is a depositional feature, but we don't see those with continental glaciation. We see those in alpine glaciation regions. And lateral moraines, those are just moraines that you see along the edge of a valley glacier, and they're made up of material that's deposited from the valley walls. So C is the incorrect answer. A winding hill of sorted sand and gravel deposits is known as a what, and is deposited by a what type of glacier? So a winding hill, anything that's winding, there's a couple of different adjectives that people choose to describe a sinuous feature. So whether it's sinuous or serpentine, kind of snake-like, or winding, S-shaped, all of those work to describe an esker. Drumlins are kind of tear-shaped drop. They're lobate shaped. Okay. So you really have to know your stuff with this question. So eskers, those are formed in continental glaciation regimes. So the correct answer is D. All right, well, looks like we got through all 40 of those pretty painlessly. Um, Hopefully this was somewhat beneficial, and hopefully it was worthwhile for people to watch. If you have any ideas for further content, either last minute review for the upcoming ASBOG exam in October, or for those of you who will be taking it either again or later when it's offered, I'd really appreciate some content suggestions. Whether that's lecture style videos or more videos like this, just walking through problems. I'm not really sure what's beneficial or most beneficial for people, or what they'd like to see. But if you have any suggestions, I'd love to hear them. Just leave them down in the comments, and I'll try to get back to you. Thanks so much for watching, and hopefully it was helpful. Bye-bye.